Hey, it's Mrs. Blankenbeckler, and it is Friday, November 4th, and you're watching this video. So, I am going to go through lesson 8.07 with you, and this is going to be probably your shortest lesson for the week, because this is the quadratics and inequalities. And this is the first problem we're going to look at today, and that is x squared plus 6x is less than or equal to negative 5. How do we graph that, and what does that look like? And I'm going to give you a few pointers on graphing these inequalities. So we've done inequalities and we've done quadratics, so we're just merging those two concepts together. The very first thing I want you to look at is your inequality sign. It says less than. Remember, that's an and problem. So when we go to do this, it's going to be an and problem. Actually, you'll see in a second, it may not be and. But first thing I'm going to do, since this is a quadratic, I'm going to put it in descending order. So I need to bring that 5 over. And whenever you bring a 5, something to the other side of the equation, you change the sign. So all this is less than or equal to 0. Okay? So now I need to factor that. So I'm going to factor this one. And this is going to be x plus 5, x plus 1, because what multiplies to 5 and adds to 6, they're both positive. This is positive, so they add to a positive 6. So my two solutions are going to be negative 5 and negative 1. Okay, so now I can graph my quadratic that actually looks like this and decide if I shade in or out. But before I do that, what you can do is give yourself a number line. And this works for all inequalities. I'm going to have a negative 5, and then a negative 1, and then of course here's 0, 1, 2, 3, 4, positive 5. So you give yourself a number line. Now what I'm going to do here is I've got some regions. I know that this is less than or equal to. So that means I'm including these roots in my solution, whether I shade between or away. I know I'm including these points because it's less than or equal to. Okay, the next thing I'm going to do is I'm going to test points in each region. Okay, I know that it's probably either going to be both away or both towards. So I'm going to test points in 1, 2, 3 different regions. So let's start out here at negative 6. I'm going to plug in negative 6 into this and see if it ends up being less than negative 5. So negative 6 quantity squared plus 6 times negative 6, that gives me 36 minus 36 is 0 less than or equal to negative 5. No, it's not. So it's not that region. So my guess is probably not that region either. So let's try one over here. Let's say 0. Okay, 0 is a nice easy one to plug in. So 0 squared plus 6 times 0, which is 0, is that less than negative 5? No, that region's not working either. So that means it's probably everything in between. So let's try it. Let's try a number between negative 5 and negative 1. So I'm just going to pick negative 2. You could pick another number too, but I'll try negative 2. Negative 2 squared plus 6 times negative 2, is that less than or equal to negative 5? 4 minus 12 is equal to negative 8, and that's less than negative 5. So that region works. So that means my shaded region is here. Now this was a less than symbol. So why did I shade between? That's an and. Well, it's because we didn't have the y on the left. Had I flipped this around and had my 0 over here, it would be 0 is greater than or equal to my equation. So if I flipped my inequality around, so my y value was on the left, that would be an and problem, greater than, and that's why. So if you want to use the and or method, make sure you're looking at the y being on the left hand side So you can do an and or. And being together, or being apart. Okay, so there's the first one where you're going to find your roots and then test it. Now, how is that going to look if you're not doing it on a number line? If you are doing it on a number line, just test your regions. That's all you have to do. Okay, if you're actually graphing it from here, what's that going to look like? Well, I kind of have my graph already done. So what I'm going to do is just kind of sketch it on a Cartesian coordinate plane. Okay, so I know I have roots at -1, 2, 3, 4, and -5. I know that my vertex is halfway between the roots. Remember that? I can take the roots, -5 plus -1 divided by 2. That's -6 divided by 2 is -3. So at -3, I'm going to have my vertex down there. What's my output, or what's my y coordinate? Remember, we plug in -3 squared plus 6 times -3 plus 5, 9 minus 18 plus 5, -9 plus 5 is -4. So that means -3, -4 is my vertex. Okay, so my vertex is -3, -4. We talked about that in one of the last lessons. Add the roots, divide by 2. That gives you the x-coordinate. That's halfway because that's a line of symmetry. To get the y-coordinate, just plug and chug into the equation. And here is my line, my parabola. Now, I'm going to draw it as a solid line, right? Because it's equal to. If it was just less than or greater than, it would be dashed. But this one's a solid line. I just discovered it's everything between that. That means my shaded region is in the center. And voila! There, I've moved it from being on a number line and testing it to actually graphing it on the Cartesian coordinate plane and shading it. Had I graphed outside in a way, well, I would have shaded on the outside of the parabola. So that's basically how you do these problems. So I'm going to stop here, give you some time to digest it, and go into the LMS and look at some of the examples. And then if you want to come back, my second video will be just a couple more examples. I'll put them up, and then you can practice them. And that's only if you need it. So hopefully these couple videos will help you get going today.